Hey, all you cool cats and kittens. Oh, wait, yeah, let's do some chemistry. All right, welcome back for part 2 of classifying reactions video. In this one, we just want to talk about one other type of reaction, which is an acid-base reaction. This is new to you. You didn't do this in grade 10 because we didn't talk about acids and bases in grade 10. Now that we have, we can just add this extra little shade of meaning on top of one of the other reactions that we already talked about. So an acid-base reaction is a double replacement reaction. So we already know what these are. So this is just a special case of a double replacement reaction. And as the name implies, it takes place between an acid and a base. Okay, we know how to recognize acids, we know how to recognize bases. Remember, we said acids are going to have that hydrogen at the start. Bases are going to have that hydroxide. In this case, the products are always water and an ionic compound, and we'll see that that makes sense in the fact that it's a double replacement anyway. When we do the double replacement, we'll see why we always have water and why we always have an ionic compound. You'll also hear them referred to as neutralization reactions. I tend to call it an acid-base reaction, but feel free to call it a neutralization reaction as well. So we're going to write two examples here and see how they differ from just a regular double replacement reaction. So here's our example 1. So we're going to use hydrochloric acid, this is aqueous, plus sodium hydroxide. So we're just going with super common acid and base here. So HCl plus NaOH. If you take a look at this, before we would have just said here's a compound, here's a compound. So that means this is a double replacement reaction, which it is. So if we're going to have a double replacement reaction, we said the positive ions switch with each other. So hydrogen and sodium are going to switch with each other. So what do we get? Sodium is going to go with chlorine. So we'll have NaCl. This will be aqueous. Plus, we'll have the hydrogen coming over here with hydroxide. So we'll have HOH. And in fact, what is HOH? Well, normally we would combine these two hydrogens and call this H2O. This is water. So this is water. And what state should we write for water? Probably liquid. So you can see we actually ended up with an ionic compound, sodium chloride, and water. And you can feel free to write it as HOH or H2O. It's really up to you. Same as always, we need to look to balance afterwards. We've got, if you write it as HOH, it's actually easier to balance. We've got one hydrogen, one chlorine, one sodium, one hydroxide, one hydroxide. So this is actually balanced. If you write it as HOH, it oftentimes will help you to balance. All right, let's do one other example where we will need to do a little bit of extra balancing. So example 2. Wow, my writing is poor. So we have H2SO4 aqueous plus KOH aqueous. So we've got our acid here. We're noticing the hydrogen at the start. We've got our base with the hydroxide. So what are we going to do? We're going to swap the positives. So we're going to swap the potassium and the hydrogen. Make sure you write neutral ionic compounds. So when potassium goes with sulfate here, we will have K2SO4, and that'll be aqueous plus the hydrogen is going to go with the hydroxide. Let's write it as HOH. And because we know it's water, we're going to write it as liquid right away. This is where writing it as HOH is actually going to help us to balance. So we have 2 hydrogen here. If you look at just right here, to balance that, we'd put a 2. You've got 1 sulfate, 1 sulfate. 1 potassium, 2 potassium. Oh, we need a 2 here. And then 2 hydroxide, and we have 2 hydroxide. So actually writing it like this helped us to balance. So I want you guys to go ahead and try the second balancing and classifying sheet. For ones that are acid-base reactions, please label them that way rather than just double replacement. If I was marking it, I would give you half a point for knowing that it was a double replacement, but I would give you a full point for knowing that it is a specific type of double replacement, an acid-base reaction. So make sure that you write that in as well.